A Tale of the Toxic Kitchen, Cooking with PFAS. Hi everyone, let's start in the kitchen. Have you ever cooked pancakes on a pan where they just slide right off? That's thanks to nonstick coatings. Nonstick cookware is super popular and used on a regular daily basis by so many people, and probably by you. Many of these pots, pans, and trays are lined with so-called forever chemicals to get that convenient nonstick surface. These forever chemicals are called PFAS and are given that name because of how long they stay in the environment and in our bodies. In the next few minutes, we'll explore what PFAS are, why they're in your cookware, how they transfer to food, what we still need to learn, and go over tips on how to make informed choices when cooking. PFAS are a large class of chemicals with over tens of thousands of different compounds. PFAS stand for per and polyfluoroalkyl substances. Super big name, I know, but that name tells us a lot about their chemistry. Alkyl means a chain of carbon atoms, like a backbone. Fluoro means fluorine atoms are attached to those carbons. Per means every possible spot is filled with fluorine, and poly means many spots are filled with fluorine, but not all. The important part is the carbon-fluorine bond. It's one of the strongest bonds in chemistry, almost like superglue, but at the atomic level. This makes PFAS super resistant to heat, water, and oil. And that's why they're used in waterproof jackets, food wrappers, and in this case, nonstick pots and pans. It also means that they don't break down quickly in nature and in our bodies, which is why people call them forever chemicals. The main nonstick material, or PFAS, in cookware is PTFE, which stands for polytetrafluoroethylene. It's a long chain made up of repeating carbon atoms, each covered with a fluorine atom. Imagine a necklace made of identical beads, all with shields on them. That shield makes the surface extremely slippery, so oil, water, and food can't easily stick to it. That's why PTFE is super popular in pots, pans, and baking trays. PTFE is very stable under normal cooking, but like any material, it has its limits. At very high temperatures, usually above 450 degrees Fahrenheit, the long PTFE chains can start to break apart. When that happens, smaller pieces of fluorocarbons can form. Some of those fragments, if they react with oxygen and water through vapor in the air, like in steam, can turn into other PFAS, including a compound called PFOA, or perfluorooctanoic acid, as well as other gases. Cooking acidic foods, like tomato sauce or lemon juice, can also put stress on the coating. Acids act a bit like chemical scissors, helping break down small parts of the PTFE chain. So, heat and acidity are the main conditions where the coating can slowly release different byproducts. Now here's the important part. Some studies have shown that too much PFAS, like PFOAs, in our bodies can be harmful to our health. High levels of PFAS could make it harder for our immune system to fight off sickness, affect our liver, and maybe even increase the chance of some cancers. The tricky part is that we don't yet know how much PFAS from cooking pans actually ends up in our bodies. But because it can build up over time, and because they're invisible to our naked eye, it's important to be aware of how exposure through cooking happens. Scientists know that PFAS can escape from coatings under certain conditions, like heat and acidity, but we don't fully know how much actually gets into the food that we eat in everyday cooking. Most of the research has been done in laboratories with new pans. Much less is known about older, scratched, or heavily used pans in real kitchens with long cooking times. That's an area where more research is still needed. So, next steps in research would be to test the levels of PFAS in various prepared meals after cooking with cookware coatings that have PFAS, like PTFE, and to test the levels of PFAS released from using old pans and pots for different cook times. This will help researchers answer questions like how much PFAS ends up in our food during regular cooking. Do older pans release more than new ones? And how do cooking methods like frying versus baking change what comes off the coating? Studies like this will help us better understand actual exposure in everyday life. In the meantime, here are some simple habits that can help your pans last longer, perform better, and reduce your exposure to PFAS. Avoid overheating nonstick pans. Medium heat usually works fine for most foods. Use wooden or silicone utensils instead of metal to prevent scratches. If a pan is badly scratched or peeling, it's probably time to replace it. And for baking, you can use parchment paper like silicone mats instead of nonstick trays. There's other cookware options too, like stainless steel, cast iron, and ceramic, which don't use PTFE coatings. So to sum up, PFAS are strong, stable chemicals that give cookware its useful non-stick properties. Under certain conditions, PTFE can break down into smaller compounds, including PFOA, which can cause health concerns. But there's still a lot to learn about how much of this matters in everyday cooking. By understanding the science and using cookware wisely, we can enjoy the benefits of nonstick surfaces while also being thoughtful about how we cook. Thanks for listening, and next time you flip a pancake, you'll know a little more about what made it slide right off the pan.